uh, let's see how we can create a spectrum and DDL for the tables by using the Python script. So this is the Python script which we have written for getting that spectrum DDL and table DDL. So you can see here, these are the Python code we have written it. So I'll show you, I'll just walk through all the way how we have passing the attributes and variables for getting the DDL. So this is the process. So it's kind. So not only limited to the DDL only, we can pass the attributes of like what are the sorts keys, what are the distribution keys, and what are the tokenized columns. So based upon that, the column which we are tokenizing, right? So we are using some kind of the algorithm to convert all the PHI and PII information to be encrypted. So for that we are tokenizing, we first identifying those columns and then tokenizing it by using that algorithm. So we'll show you the algorithm as well. So but before that I just wanted to capture all these things, and this is not for others use, this is for my personal use, so that in future I can develop if anything comes right, so I can develop this kind of the infrastructure again. So this is all about this Python script. Okay, so I just put this Python script in some folder, and from that folder I'm going through, like we have to call this folder. 1 minute, I'm coming. So we are using this Python script and coming to the other things. So this is the, here you can see we have created this as a Python file. Okay, and then inside that the two files we are using, which is calling inside this Python. So let's open this. So this is the like open any table, okay, in SQL Server, and taking all the columns information over here, and this is for the production table. So based upon the production table we are changing the kind of environment in the redshifts and glue, and uh, only main table is n. That means like if you wanted only the uh, table DDL or in spectrum both. So if you are looking for the spectrum, so you need to put it n over here, and these are the sort key, and these are the, this is like a dist key and primary columns, and the table information is required. Okay, apart from this, coming to the spectrum structures, that was the table structure, first one. So in spectrum structure we are getting token column, if it is tokenized then S, if you have the token column, otherwise you can put y. Now the token column I am putting here, okay, and then the column name which we are getting by using the script, these columns name which is in ascending or descending order. So I am showing you how we can take that column information. So this is the SQL script which we are getting, like which we are using to get the find out the tokenized column. So based upon our requirements, right, or based upon our the columns which is sensitive, so we can put here in you can see here in single quote we put all the column which we are thinking is PHI or PII information, and running this information, so that if any column which is belongs to this, that will be come out in a kind of result set as a tokenized column. So this is from here we are taking the tokenized column. Let's go to other script which is giving us. So this is the script from which I told, right, this is giving us 1 minute, let me expand this. Okay, so this is the script which is giving me the all columns name, okay, so which is in ascending order. So you can see here, so this is the script. So now coming to the P2 process, or P2 means we just given a name over here. P2 means phase 2 process. So in phase 2 process we have gone through table DDL and 1 minute P2 creation. Okay, so here you can see, right, table structure, spectrum table structure we passed, and we passed the input table spectrum. Okay, now once you run the Python script, right, so output will be created like this. So output table, you just need to copy this script and paste it into your redshifts and run it, so it will create a spectrum as well as table DDL. So here you can see whatever the token columns we have passed, that information is there, and these are the column name. Okay, and here you can see short key, dist key and primary key, whatever we have passed that is there, and these are the interleave short keys. And then below you can see the spectrum DDL. Okay, so in spectrum DDL we have passed all the tokenized column and all. So it's like by using the Python, manually you can do, but by using the Python script, right, you can easily create it. So here we are passing some special characters over here to remove it. Okay, so whenever we are passing any special character separators, okay, escape characters, so that is we are excluding from our record sets or data sets which we are going to read. Now once it is done, so what you have to do, you have to create a CFT. Okay, so in CFT sites, so there are two types, one is tokenized and one is non-tokenized. So let's go through the first tokenized. Okay, so tokenized column. Okay, so here this is the YAML. Okay, YAML script. So in this script, this is the like kind of template which we are using to create glue jobs. But like here AWS template version, and we have put the date description. You can put the description of the CFT. Okay, so that will be passed to glue jobs, and the parameters and notification buckets and type string default, this is the bucket name. Okay, default bucket name, and resources, and then glue job name. So types we are passing AWS glue jobs properties, and then command. Okay, so in command we are passing Python shell, and here you can see, right, in S3 bucket this is the this is the Python script. Okay, which we are using, we are running it. Okay, and inside that Python script we are consuming these attributes, you can say parameters. Okay, so in these parameters we are passing the connections with the redshifts and the server where you are pulling the data. So we are pulling the data from SQL server, which we have given name 020 cmd, and then here default arguments. These arguments are required and which is passed inside the glue job. So these are the instance name, job name, okay, load type full, and server information, and source table information, modified date, broker certificate. So this is primary table information, and environment, okay, and redshift environment, and bucket name, and tokenized column over here, and token type, which is whether it is dob name and id. Okay, so target table name. So what is the redshift table name here? Because we are pulling the data from SQL server to redshifts. Okay, so here require bcp true and require tokenized true. Now here extra files. So this is the path of the s3 bucket where we have put our cmd functions. Okay, so that we are using calling it, and below here this is, so this is the template. So let's go through the let's go to aws glue job. So whatever now we have to copy this template and go to the cloud formation. In cloud formation we have to paste it. So we have to just copy, you can open any glue template, okay, which is already sorry cloud formation template which is already created. In that you just need to copy from here resources, okay, below the resources, and paste it, and then validate the template, and then upload it. So once you upload, so it will create a new glue job. So now let's go to the glue job. So here I just open a glue job which is reading the data from the SQL server, okay, and loading it. So this is the python script which is automatically that is written by using the cloud formation. Okay, so this is like a common for all. Okay, so here you can see. So this is the kind of general script which we are using for all. Okay, and here a job that that we have given in our cloud formation. This is the kind of definition we have given, right? So all of the thing is coming here automatically. This job will be created, python shell script, python script, and then here data processing unit, nothing you have to select here. Okay, except im roles. Okay, so here we have to choose the im roles, but by script we can do it automatically, but when manually we are creating, right, copying paste. So in that scenario we need it. And now coming to here, so here we have to pass the connections. Okay, so bpc connections. For here you can see choose a bpc configuration to access Amazon s3. So here we have chosen two redshifts. Okay, and then these are the attributes which we have passed in our safety. Okay, so you can see here all the attributes is passed over here. Okay, now after passing all these attributes we can run it, and it will fetch the data from SQL server and put it into AWS Redshifts. So let's go to the script, okay, which we used like a python script. Here it will be there somewhere here. So it is in D drive projects cmd redshifts data migration. Okay, so let's go over there. Let's see whether we have access or not. Let's see the file code. So this is our s3 bucket. Here you can see, and this is the path where we have put it. So inside the safety project script. Okay, and let's see where we have to go. Project script, and then SQL to redshifts dm. So let's go SQL to redshift. So these are the script. Okay, SQL to redshifts dm. So this is the script. Okay, here there are many script. Okay, so data migration portability, that means version 2, and direct migration. So there is where there is let me download it, where there is encryption required, so it is there. Okay, so for the encryption and direct migration is also there. So let's will open all these three. So this is the script which is we have used for the tokenization. Okay, so here you can see. Let's scroll it. So this is all about this code. Okay, let's go with the direct migration. So in direct migration, this is the script. Okay, so in this script you can see here, and let's scroll it. This is the script. These are the script, right, which we are using inside our glue jobs. So this is all about the Python script creating the glue job by using the CFT and P2 process. This is the merge operations SQL procedure which we have written for our incremental load. Okay, so I'll show you the state machine as well, but right now I'm showing you not state machine, it's a SSIS procedure, but right now I'm showing you how we can write the merge operation and how pretty we have handled the logging things over here. Okay, so here we are returning the code because this procedure we are running by using the SSIS package, and in that SSIS package this error code we are like reading out over there by using some automated tool which is automated enterprise edition, which we are using to run all these SSIS procedure. And in that written code, by using the written code we are handling the error. So okay, here we have defined few objects. Okay, new load version id which we are inserting for each batch, so we can easily identify by using the new load version id, like suppose someday. Okay, how many times it got ran and how much record is loaded for across all the record for a one time load. New load version id will be same. Insert row, how many inserted, updated and deleted count. So this is the table in which we are load version id is already there, we are just incrementing one value of it and creating a new load version id, and then load version id we are assigning to the variables and updating the ACS task in which we are managing our failure, or like what kind of the operation is happening, whether it is completed, failed. So that kind of the things we are capturing over here. So at the starting we mark it as in progress, once it is completed, so marking it as successfully completed. So suppose if it is in mid of that, okay, procedure got failed, so in that scenario we are capturing that information error logs and putting it in as a t underscore status. So here this is the mar operation which is be performing on the fact table by using the delta tables. So when matching, okay, when not matched by the source, by the target, then insert. And when matching, okay, in that scenario we are insert updating it. Okay, and then capturing the insert, update and delete log over here. So here you can see inserted, updated. Okay, and here how we beautifully we have uh, like inserting the task post executed. Okay, it's inserted how many record, how many expired and updated. And here we are uh, passing new load version id and updating the ACS task. And then later we are this code is we have written to handle the errors. Okay, so if it is failing, so we are giving the error message, and by using the error message function, we are inserting into it. Okay, server version name and all. So this is incremental load. And let me show you the SSIS package as well. So this is the SSIS package. Okay, in this we will see how we have created it. Okay, so first of all, we are using ACS pre-task and post-task. In pre-task, we are using this SQL statement. Okay, we are passing all the values, but this is not direct SQL. We have put it. Okay, by using expression. So I'm showing you how we can put it. Expression. Okay, go to expression, and here in expression we have written this code. So if I open this, so here if you enlarge this, so here you can see this is the code which we are running. Okay, this is the code which we are running it. So if I evaluate it, so the values which we were mm, checking over there, that is the same. We are going to get it. Okay, so let's close this. And let's close this. So we starting we are updating ACS task as in progress, and there is at the last one step is ACS post task. So that means that is updating. And then here we are truncating the employer. This is delta table, we are first truncating it. And then let's go to next step, getting the max key or logic. Okay, based on the some primary key. Okay, we are getting the max key. Okay, and here this is the query which is we are using for max key. And then after once max key we get, so here we have written our logic in this, how we are connecting it. So this is the view which we have written to. By using this view, we are taking the data from the stage table, which is this view is nothing, just uh, joining between a stage table and dimension and fact tables, which is mostly using left join. Once that is done, here we are generating hash key component. Okay, so in hash key we are selecting some columns on which if any value is changing, so we are considering it as a update. And if nothing is matching, so that means that is insert. Okay, so after hash key we are generating primary key, and here we are nothing, we are just encrypting the max key value which we are taken previously. Okay, so let's open this. So here you can see the logic what we have written over here. We just incrementing the employer address key plus 1 as a max key. Okay, so let's close this and cancel this. And then after that, derived column, we are passing some values, columns values over here. Okay, so let's close this. And then finally we are dumping the data into here delta table. And once delta table is completed, okay, so we are running our merge sp, so truncating the dnb history over here. So that is nothing, just kind of stage table. Okay, so but this is not required. uh, Move the data to history. Okay, from dnb table to history, and prepare the data. Okay, so this is the load in which we are loading the data, but finally we are loading we are running after the delta process, our merge process. Okay, so merge process will be here. You can see the procedure name is there, in that merge operation is happening. So and here these are the variables. Okay, coming to the package explorer, content parameters. Okay, so no project parameter is passed. And if I come here, properties, so here you can see nothing is there. If I connect here, okay, I go to here, SQL Server we have selected. Here nothing is there. Deployment model we have chosen is true. Debugging, we set it false. So this is how we have built our SSIS package. Okay, and this is all about our process.